Welcome to the Explainer. We've been fueling our cars pretty much the exact same way for, over a century now, just physically plugging a heavy hose or a thick cable right into a machine. Well, today we're diving into the source material on a technology that's gearing up to make all of that completely invisible. We're talking about wireless electric vehicle charging. We're looking at an engineering breakthrough that basically takes a purely mechanical, everyday chore and turns it into something totally effortless.
Seriously, I want you to imagine never having to deal with those clunky, weather-beaten conductive cables ever again. What if charging your car was literally as effortless as just pulling into a parking spot at the grocery store? Or, and get this, even just driving down the highway? That is the wild promise of wireless power transfer for electric vehicles. It honestly sounds like absolute magic, right? But as you'll see, it is pure, highly optimized engineering.
To really understand this tech, we're going to use a zoom-in framework today. First up, the EV charging hurdle. Second, a century of wireless power. Third, how wireless charging actually works. Fourth, the anatomy of a charging pad. And finally, number 5, the ultimate quest for efficiency.
All right, let's jump right into Section 1, the EV charging hurdle, moving beyond the plug. Let's establish exactly why we even need wireless charging in the first place. Look, we all know EVs are absolutely critical for cutting down emissions. But let's be real, widespread adoption is kind of hitting a wall right now. We're talking about severe range anxiety, those agonizing wait times at the station, and honestly, just the pure hassle of wrestling with cold, wet, clunky cables in the freezing rain. It's not great. Wireless charging goes directly after these hurdles. By completely eliminating physical connections, it makes the whole process autonomous. It even opens the door to dynamic charging, basically meaning your car could actually charge while it's driving down the road. How cool is that?
Moving on to Section 2, a century of wireless power, from Tesla to today. Now, you might be thinking this is brand new sci-fi tech, right? Actually, it builds on over a century of scientific history.
This whole journey actually traces all the way back to 1873. That's when James Clerk Maxwell first predicted electromagnetic waves. But the real spectacle? That happened in 1899. Nikola Tesla actually built this massive 200-foot-tall tower, and he attempted to literally beam 300 kilowatts of power right through the air. I mean, it didn't work for mass distribution, obviously, but the seed was planted. Fast forward to 1972, when Professor Don Otto proposed an inductively powered car, and then finally to 2013. That's when inductive charging for EVs actually became a commercial reality.
Okay, Section 3, how wireless charging works. The magic of induction. So, how do we actually beam that massive amount of power into a modern vehicle without, just losing it all into thin air?
Well, the whole shebang relies on something called inductive power transfer, or IPT for short. Now, instead of using far-field transmission like radio waves or microwaves, which, by the way, would be incredibly dangerous and super inefficient for this much power, IPT uses near-field magnetic induction. Essentially, what you're doing is generating a magnetic field at a specific super high frequency, usually somewhere between 79 and 90 kilohertz, and that safely bridges the physical air gap between a pad sitting on the road and a pad attached under your car.
Let's map out the incredible journey of electricity, starting all the way from the city grid right into your car's battery. So the grid supplies standard power to the primary coupler. There, a high-frequency inverter instantly chops it into an incredibly fast alternating current. This current then rushes straight into the ground pad, which generates a really powerful magnetic field. The receiver pad under your car catches that field, turns it back into DC voltage, and feeds it safely into the battery. And honestly, the craziest part? All of this is happening while the car and the pad are constantly communicating wirelessly just to align perfectly and even process your payment.
Let's zoom in a bit more for Section 4, anatomy of a charging pad zooming into the hardware. Because to generate a magnetic field that strong, you need some seriously specialized hardware hidden inside those pads.
You can kind of think of the charging pad like a highly engineered sandwich. At the very bottom, you've got an aluminum backing plate. That's absolutely vital for containment because it stops the magnetic field from just shooting uselessly downward into the dirt. Right above that, we have a ferrite core to tightly direct the magnetic flux upwards. Then sits the real star of the show, the specialized Litz wire coil that carries the actual current. And finally, the whole thing is capped off with a super durable plastic cover. I mean, it has to withstand the full weight of a car and, of course, the outdoor element.
Which brings us right to Section 5, the quest for efficiency, engineering the perfect wire and coil.
Now we're getting down to the microscopic level and the ultimate engineering trade-off.
Here's the problem. At high frequencies, standard solid copper suffers from something called the skin effect. Basically, it pushes the current to the outer edges of the wire, which creates massive resistance and a ton of heat. No good. So engineers use what's called Let's wire. Think of it as dozens of tiny, twisted, individually insulated strands. But the innovation absolutely doesn't stop there. Engineers are actively experimenting with magnetic plates to boost efficiency, magnetic powder coatings to slash manufacturing costs, and, get this, even RBCO. That is a literal superconducting wire with near zero energy loss. Every single choice here is just a brutal balancing act between your budget and absolute peak performance.
And when we zoom out from the individual wire to the overall shape of the coil itself, the complexity just skyrockets. You have your basic single coil shapes, like circular or rectangular pads, which are, relatively simple. But to really crank up the performance, engineers are moving to advanced multiple coil configurations. They're literally overlapping and interlocking the wires in these highly complex patterns.
So why make it so ridiculously complicated? Honestly, it comes down to human error. See, with simple single coils, if you park even a few inches off center, you completely lose your charge. But complex, multiple coil pads, like a double D or a quad D quadrature, they give you this massive charging zone. You can park completely sloppily, and the car still charges perfectly. The catch, of course, is that they require vastly more material, not to mention incredibly sophisticated control systems just to manage the interference between all those overlapping magnetic fields. Now, to manage the magnetic flux generated by all those overlapping coils, designers use highly specialized ferrite cores. You'll see them shaped like bars or plates or even U-shapes. These highly conductive materials act like a magnifying glass and a shield all at the exact same time. They focus the magnetic field exactly where it needs to go, straight up into the car, and they prevent any of that precious energy from leaking out to the sides. It's really just an ingenious way to keep the pads lightweight while maintaining some pretty intense performance.
At the end of the day, wireless EV charging is a huge balancing act. On one side, we have unparalleled convenience and safety. Literally zero cables to trip over, completely weatherproof systems, and fully autonomous operation. But on the flip side, we've got some heavy realities to face. These units are expensive, and physically tearing up solid concrete to integrate them into our roads and driveways, that is massive, labor-intensive infrastructure work. Plus, if things aren't engineered to absolute perfection, you lose precious electrical efficiency.
But the science is proven, and honestly, the efficiency is climbing every single day. So we are left with a massive question for the future of transportation. As this technology gets cheaper and far more efficient, is invisible wireless charging going to be the ultimate feature that finally convinces the world to abandon the gas pump forever? Thank you so much for joining us for this explainer. Keep your eyes on the road ahead.